It was a cloudy day in Chile. I had been exploring for weeks and seeing so many waterfalls, cool birds, and of course, igneous rocks. I knew my time there was soon coming to an end. As I walked and thought about Chile, there was a flash, and I found myself standing on some really dark rocks, and behind me were a whole bunch of rocks with stripes. I looked at the stripes and I wondered, where did the stripes come from? I looked at the dark rocks on the ground and I wondered, where did the dark rocks come from? So I walked along the rocks, noticing the dark rocks and noticing the striped rocks. And as I looked at all the rocks, I wondered, how are these different kinds of rocks formed? Since I had spent most of my other trips thinking about igneous rocks, now it was time to think about the rocks with the stripes. I remember when I drove, I looked along the side of the road, and as I looked along the side of the road, there were lots of areas that seemed to have stripes in the small cliffs that were cut out when they built the road. We drove slowly by the cliffs, and the cliffs seemed to change. And as the cliff changed, a forest seemed to grow. And almost as if I was driving in a time warp, the whole world started spinning! And spinning, 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 spinning. As I kept spinning, I thought to myself, those stripes in the rocks were very cool. And I remembered that I may have seen some striped rocks before. I saw striped rocks in the mountains of West Virginia. I saw striped rocks in the canyons between the cornfields of central Kansas. I saw striped rocks in caves near the Potomac River in Maryland. I saw striped rocks along the streams, cutting through the forests near Bloomington, Indiana. And in the high plateaus of Colorado and Utah, there were rocks with stripes almost everywhere. And I even saw some striped rocks near some of the beaches in Costa Rica. I had heard that these rocks might have been formed by sediments. Sediments are sand, clay, and small rocks at the bottom of lakes, rivers, marshy areas, and especially oceans. I remembered on another adventure, I went snorkeling, and as I looked through the waves, I noticed that some of the sand was floating in the water. That made the water cloudy. And I also noticed that other sand was forming patterns on the ocean floor. Later, when I walked on the beach, I saw those same patterns on the drying beach. And as I walked on the beach, I noticed some places where the sand was different colors. Light in some places and dark in others. When I dug a hole in the sand, I noticed that those colors actually formed layers and stripes, just like I had seen along the side of the road and in the National Park of Chile. Once upon a time, all of the sediments, the sand, the clay, even tiny rocks, were floating or at least moving around in a very rough ocean, a roaring river, or even a rising stream. As the ocean calmed and the rivers and streams slowed down, the larger and heavier rocks and sand quickly fell to the bottom of the stream bed or the ocean floor. Meanwhile, the smaller and lighter sand sank more slowly. As each kind of sediment fell to the bottom faster or slower, based on its weight, layers were formed. While some of those layers are hard to see because they're deep under the water, other layers are still forming today, and we can see them when we go on a trip to the beach. During big storms, all of this sand is jumbled up in the ocean, but then the heavier sand falls faster and the lighter sand falls slower. Over time, those layers in the sand get compacted and cemented together, and over lots of time, they turn into sedimentary rocks. And these sedimentary rocks of cemented sand or clay or mud or small rocks are all called clastic sedimentary rocks. Clastic sedimentary rocks are rocks that are cemented pieces of little sediments. While layers are an excellent clue to identify that a rock is sedimentary, looking more closely, we can actually see the sediments that make each layer of a sedimentary rock. So we know that it's a sedimentary rock. How do we know what kind of sedimentary rock? The kind of sedimentary rock is determined by the kinds of sediments that make the rock. Sandstone may be the simplest type of sedimentary rock to identify. Look for little grains of sand in each of the layers, and sometimes you can see grains of sand even when there are no layers. These sandy cliffs along the shore of the Potomac River in southern Maryland were formed by sediments eroding from the Appalachian Mountains over millions of years. Some of these sediments have compacted and cemented together to form clastic sedimentary rocks. And because we can see the individual grains of sands in these sedimentary rocks, these rocks are also sandstone. Sandy sediments make sandstone rock. Here is some sandstone from the beaches in Costa Rica. Sandstone can be found all over the world. Mud is often found at the bottom of shallow marshes or shallow oceans, where the water is moving very slowly. As mud piles up, it compacts and compacts to form mudstone rocks. Mudstone rocks were made of mud, and since mud has very small sediments, mudstone has the smallest grains making up the rock, and the grains can be hardest to see. Shale is similar to mudstone. It is also formed by mud in large wet areas where mud piles up on top of more mud. While mudstone and shale may look similar at first, mudstone can be quite hard to break, while shale can be very brittle and often breaks right in your hands. The crumbling ones right above me, that's the shale. Very, very thin layers that crumble in your hands. Over here, we have some of the more blocky layers. Those are mudstone. Shale is crumbly, mudstone is blocky. Instead of sand or mud, sometimes small rocks find themselves on the bottom of a great sea floor, and they get cemented together by little bits of sand or mud in between the rocks. When this happens, a rock called conglomerate is formed. Conglomerate is a rock made of lots of little rocks. Sometimes they're rounded rocks, sometimes they're bigger or odd-shaped rocks, and sometimes the rocks can actually be small, rectangular crystals. These special sedimentary rocks are called breccia. Conglomerate rocks are lots of rocks stuck together, and when those rocks aren't just rocks, but actually crystals and rectangular featured rocks, we call it breccia. Conglomerate and breccia, two rocks that are lots of rocks stuck together. Sandstone, mudstone or siltstone, shale, conglomerate, and breccia are different kinds of clastic sedimentary rocks. Organic sedimentary rocks. Organic sedimentary rocks are rocks that come from pieces of once living things. Coal and limestone are two kinds of organic sedimentary rocks that you might find. Coal is often formed when lots and lots of plants and even some animal debris pile up at the bottom of swamps or river deltas. Limestone is another kind of organic sedimentary rock. Limestone is formed by crushed shells or other things that are high in calcium, like bones from dead animals or coral reefs. Whenever you find large quantities of limestone, there's a good chance there used to be an ocean in the area where today there is limestone. Many caves are made of limestone rock. Limestone is a sedimentary rock that contains high concentrations of the mineral calcium carbonate. Now, you've probably heard of calcium, and I know you've heard of carbon. Calcium is the element that keeps our bones strong, and it's an element found in shells. The walls of this cave are made of limestone. As water drips in from the ground above, the limestone weathers and erodes or washes away, making the cave bigger and bigger, little by little. Limestone is an organic sedimentary rock made of small pieces of shells, bones, and coral. The last kind of sedimentary rock that we're going to look at are chemical sedimentary rocks. Chemical sedimentary rocks are formed when lots of minerals are dissolved in water and that water evaporates. Over time, the rock is formed as the minerals arrange themselves, and these rocks, chemical sedimentary, often have crystals or things that look like crystals. Geodes are one of the most fun and famous kinds of chemical sedimentary rocks.
And this has these big giant balls. This one's more solid quartz with a little dark inside, and then this one has these really bright little crystals.
Geodes look like rocks on the outside and have crystals or other mineral formations on the inside. Chert is also a chemical sedimentary rock. Chert often has sharp edges that can be used to create sparks when the rocks are banged together or banged against steel. So my friends, there you have our overview of sedimentary rocks. Sedimentary rocks come from sediments, and sediments come from broken rocks and other things. Clastic sedimentary rocks are when the pieces or sediments are glued together. Organic sedimentary rocks come from sediments that include pieces of living things or once living things. And chemical sedimentary rocks come from sediments that were dissolved in water. Always remember, all sedimentary rocks, all the pieces of sedimentary rocks came from other rocks or pieces of long dead living things.